In the next few minutes, you're going to understand the biggest issue with AI that we saw in 2025 and why we're going to continue to see it in 2026. In this video, you're going to understand the generalization gap, why you can only use AI for some certain tasks, and ultimately that AGI is not even remotely close, despite what everyone is saying. So let's kind of set the stage with the paradox of 25 and 26. Now, this is important to understand. We have kind of two camps taking place. We have unprecedented investment. Now, this is pretty common knowledge at this point. If you live under a rock, just know that the AI industry poured hundreds of billions into compute infrastructure, with frontier labs racing to build ever larger clusters. It felt like every day in 2025 there was a new model or just some type of AI news hitting the main page. And that's why, because there was just, again, we're in this AI race. GPT-5, you had Gemini, you had Claude, all just pushing out models every other week, right? And each consumed training budgets that would have seemed unthinkable just 3 years ago. Again, the numbers currently within this space are absolutely ridiculous, right? And they keep getting bigger. Yet, despite all that stuff, right, us trying to get closer to AGI, there's a massive scaling effort, right? We're witnessing something peculiar take place, and that is the goalpost keeps moving. So we don't really know what true AGI looks like. Now, the problem with this race is, again, the goalpost keeps moving because there's not really a goalpost. Again, the alignment with AI and humanity, you read kind of any book, any literature, is kind of the biggest thing at the moment. I mean, you can't really overshoot it, and if you do, we're too far gone. And so you have to be very careful with that. However, just note the goalpost keeps moving. Each breakthrough is quickly reframed as not real intelligence once achieved, right? So now that's kind of the one camp. And then the next camp is limited economic impact. And so we have broad economic automation remains frustratingly out of reach. So while AI excels at specific tasks, code generation, I mean, use Claude 4.5, use Opus 4.5, it is unbelievable the things we can now do that literally a few months ago we could never even fathom of doing, we can do, right? With just a simple prompt, right? We have image synthesis, but Banana 2 is mind-blowing. And then we have chat interfaces, right? However, it struggles with messy context-dependent work that defines most jobs. And we'll get more into that because that is super, super important to understand, right? So the disconnect is stark. Models can pass the bar exam, but can't reliably manage a small business's Excel workflow without extensive handholding. And so then we have the reinforcement learning trap. So current RL systems optimize for narrow, verifiable rewards. All right, they're brilliant at games with clear win conditions. That's why chess, Go, protein folding, it works, right? Again, there's goalposts, there's rules. It's black and white. However, this all kind of falls apart outside their training distribution. And then we have the human learner. If you tried learning anything, you would realize that humans learn through messy, open-ended exploration. If you're learning an instrument, a language, any type of sport, it's messy. It's not easy. It's difficult, ups and downs, you know. And so we generalize from sparse feedback, adjust to new contexts on the fly, and transfer knowledge across domains without millions of examples. However, with AI, the fundamental tension is training on verifiable outcomes, mathematical proofs, code that compels, benchmark scores, as we can see, you know, all these models are getting rated on, doesn't solve real world job complexity. All right, most valuable work has fuzzy success criteria. It's not black and white, delayed feedback loops, in context that changes consistently. And again, you have this kind of, I believe as Einstein says, it's kind of the theory and practical aspect of things. In theory, it sounds great, right? We're going to use these models and this and this and this. In practice, again, there's a lot of bottlenecks we're currently seeing with all this usage. And then we have the pre-baking problem, which goes back to the generalization gap. And here's the dirty secret of 2025-26 AI's capabilities. So labs are essentially running a supply chain of PhDs to manually encode skills that models should be learning autonomously. Now, what they're trying to do with these models is essentially hire a bunch of experts and put in very domain specific use cases for these models. You know, and then another thing would be web navigation, where the browser automation requires carefully curated demonstrations of clicking, scrolling, form filling across thousands of websites. You know, if you use anti-gravity, for instance, there is a browser feature where it can actually start maneuvering within your browser. What they're doing there is they're getting very specific use cases, again, of scrolling, of clicking, of X, Y, and Z. Rather, humans would just go on any website and just start clicking around. And you start to understand because you have those references. Again, AI cannot generalize like that. So the approach is fundamentally unscalable. A human employee learns Excel in a week of on-the-job practice. So why are we spending millions to pre-bake what should emerge from general learning ability? So essentially, the AI should just learn autonomously, just through practice or maybe through usage. This big generalization gap where it can solve the bar exam, however, it can't use Excel. However, it can't do X, Y, and Z, and it needs very specific. Imagine the amount of resources and compute needed to be able to do that at scale. And then obviously we have a big category in robotics, and they kind of provide us with the ultimate litmus test. And so despite years of research and massive compute, as we talked about prior, robots still can't reliably perform tasks that human toddlers master in minutes. And so the industry narrative insists that it's a hardware problem, right? You need better this, better arms, maybe better mechanics, right? Precise sensors, all this other stuff. But that's missing kind of the point entirely. Robotics is an algorithm problem. If AI models were truly human-like learners, you could show a robot how to fold a shirt once, just like a human, and it would generalize to towels, jeans, tablecloths. Instead, we need thousands of demonstrations for each clothing category, carefully curated by human teleoperators. And it's going to take a ton of time because currently right now, the only solution is just at mass scale do this. And it's going to, again, cost a lot of money, a lot of energy, a lot of compute to kind of do this operation. So this is kind of the holy grail of continual learning. What's the actual path forward? The answer lies in developing systems that can learn continuously from experience, updating their capabilities on the fly rather than requiring massive retraining cycles, just like humans. So kind of the continual learning cycle is specialized agents. So you'd have task-specific modules that develop through practice and experience. We have active learning systems that seek out the right information at the right time, learning from minimal demonstrations. And then with persistent memory, as that's super important, long-term retention of learned skills and knowledge without catastrophic forgetting, and then cognitive core. So a shared reasoning engine that handles general problem solving, abstraction, and transfer learning across domains. Again, being kind of the main point where they're not great at generalization. If you leave it up to the model, you're going to get some random thing. And that's because it's a black box and we really don't know how it's coming up with that output. And so when it comes to something like this, you're going to need something that has shared reasoning, that handles general problem solving, abstraction, and transfers across learning domains, right? So this isn't about scaling up current architecture. It's about fundamentally different learning dynamics and totally. So the hive mind model where every instance shares the same weights is elegant but wrong. So just to finish off here, let's look onto the conclusion of 2020-30 and beyond. As I said, AGI is not even close. So here's the forecast for the next 5 years. So we have impressiveness at short-term timelines. So models will continue to get more impressive on benchmarks and demos. We'll see stunning capabilities in constrained domains, right? Better code generation, more coherent long form writing. The demos will be breathtaking. Like they are already. That's just further going to excel down. I can't wait to see what the future holds when it comes to stuff like this. So we have usefulness at long timelines, but genuine economic utility will advance more slowly. So the gap between can do X in a demo and reliably do X in production will remain frustratingly wide, as it currently already is. Real-world development will continue to require extensive human oversight and custom engineering. So again, it's great in theory, but in practice, there's a disconnect, a massive disconnect. And so the competitive podium between frontier labs will stay tight because scaling compute alone doesn't solve the generalization problem. The lab that cracks continual learning, right? So continual learning, true on-the-job skill acquisition will pull decisively ahead because that's when the true use case, and ultimately it's very quick just to implement into any infrastructure and you will have, you know, a 10 out of 10 employee by your side. And until then, we're kind of all stuck in the same pre-baking trap, just with different sized ovens. And so trillions in potential revenue remain locked behind a learning bottleneck that money alone really can't solve. And so the question for 2025 to 2030 isn't who can build the biggest cluster, it's who can build systems that actually learn like humans do, because that is the $1 trillion question. As always, my friends, I'll see you tomorrow.